This is a torsional vibration model. It was built by Mr. Tim Titus, who is an engineer at Merck Cruiser as we speak. And it consists of 3 steel discs. Each one has its own collet, a chuck. The chucks came from Dremel tools, so they're able to grip very small wire. The wire is 035 MIG wire, and it is tensioned in by this screw device up on the top. And the interesting thing about a model like this is that we can have a very large linear motion. Very few vibration examples will stay linear at large amplitudes. And this one, it is quite linear, even though we wind these discs up to 360 degrees or even greater. This is the principle of the torsional pendulum clock that has been made for many, many years in Germany, I believe. Having 3 masses, we can expect to find 3 modes of vibration again. And the lowest mode is when the wheels all turn together like this. And if we check the frequency of this by just counting the cycles with a stopwatch, we'd see that it's pretty linear, even though we might give it a much larger amplitude. We get higher velocities, but the amplitude still is sinusoidal, and it's quite linear. Now the second mode is when the top wheel will turn one way and the bottom wheel turns in the opposite direction. And then the third mode would be when the center wheel is traveling in the opposite direction of the top and bottom. I'll try to do this with an angular velocity start. Now then, if we excite all of these by giving it an asymmetrical start, if I give wheel number 1 a twist without allowing the others to twist, it should excite all 3 modes, and again we will see the beating effect that we witnessed in some of the lateral pendulum problems. This model, since it has the chucks, it gives the freedom to do several different kinds of experiments. For instance, now the coupling between the center mass and the end masses is fairly weak because the springs are so long. So we might have quite a bit of difference in the frequencies, whereas the fundamental would be fairly high owing to the short length of the mass, and my arms aren't long enough that I can do this. And then the second mode would be, I'm going to cheat and hold that. The second mode would be like this. So we can play around with the stiffness matrix and the equations by adjusting the relative strengths of the 4 coupling springs, the 4 springs, and we can make a wide variety of situations then, having considerably a large number of modes of vibration, or different patterns of vibration, I should say.